This lesson is for Thursday, December 5th. It's on family of lines, and that's going to include parallel and perpendicular lines. It's also going to include changing slope and changing y-intercept and kind of seeing what happens to lines when we do that. Okay. The first part of the notes here says that parallel lines have the same rate of change. Another word for that is slope. To see if lines are parallel, we need to check the slope and see if they are equal. Okay. Well, to check the slope, we got to get them into y equals mx plus b, and we're going to be focusing on the m. Okay. So I'm going to write these out here, side by side. 3x minus 6y equals 18, and then 2x minus 4y equals 8. And we're going to solve these for y. So I box, draw my line down, minus 3x, minus 3x. That cancels out. Negative 6y equals, I write this into an mx plus b form, negative 3x, and that's a positive 18. Then we divide everything by negative 6. Y equals, the 6's cancel, negative 3 divided by negative 6. Type that in my calculator and Math 1 enter, and I get 1/2 x. Then 18 divided by negative 6 is negative 3. So there is my slope for that one. This one, same thing. Box, draw down, minus 2x, minus 2x, negative 4y equals, write this into an mx plus b form, plus 8, divide everything by negative 4, those cancel, y equals, negative 2 divided by negative 4, Math 1 enter, is 1/2. 8 divided by negative 4 is negative 2. And this one also has a slope of 1/2, so these are parallel. Okay. I want you to try this set on your own and bring that one to class completed. The next part here is about perpendicular. And perpendicular lines are lines that cross and make a 90-degree angle. Okay. And parallel lines that we talked about on the other page, parallels are lines that never intersect. Okay. So perpendicular lines have slopes that are negative reciprocals. Negative reciprocals are fractions which the signs are opposites, so one's positive and one's negative, and the numbers are flipped. Okay. So some examples of that would be if we had 2/3, the reciprocal of it would be 3/2, but the negative reciprocal would be negative 3/2. So we flip the numbers and change the sign. If we had negative 4/3, we flip 3 like that, and we change it to positive. It gets a little tricky when you have whole numbers. Like if I had 5, you have to think of that as 5/1. So when you flip it, it becomes 1/5, and it would be negative. And if we have 1/2, 1/2 would flip to be 2/1, make it negative, but that would be negative 2. To see if lines are perpendicular, we need to check the slopes again and see if they are negative reciprocals. Okay. This set here is already solved for you, so you can just look at those. 3/1 and negative 3/1. If you flipped it, that would go down there, and that would go up there. So these are not perpendicular. Okay. This set here, we would solve them for y. So I'm just going to rewrite the second one over here. For the first one, 2x minus 4y equals 8. I'll solve this one, box that, draw my line down, minus 6x. That cancels out. This becomes 3y equals negative 6x plus 18. Divide by 3, and by 3. You get y equals negative 6 divided by 3 is negative 2x plus 18 divided by 3 is 6. So there is my slope on that one. This one I box, draw my line down, subtract 2x from both sides. This becomes negative 4y equals negative 2x plus 8. Divide everything by negative 4. Y equals negative 2 divided by negative 4. If I do that, math 1 enter in my calculator, I get 1/2 x. 18 divided by negative 4 is negative 2. Okay. So my two slopes that I got are negative 2 over 1 and 1 over 2. If I flip that, it would go down there. That would come up here. This one's negative, that one's positive. So this is a yes, they are perpendicular. You guys give this one a try on your notes and bring it to class completed next time. Alright, the next part is on exploring changes in M and B. So we're going to change the slope and we're going to change the y-intercept and see what happens to our line. Okay. This dotted line that goes across here, this is known as the parent function. This is what every line starts out being. The parent function has a slope of 1 and a y-intercept of 0. It's y equals x, which is y equals 1x plus nothing. It crosses here, and it always goes up 1 over 1, up 1 over 1, up 1 over 1. Okay? We compare everything to that when we're comparing these lines. So I'm going to graph y equals 2x. So this is 2x plus 0. So I start here at 0. Has a slope of 2 over 1, so that means I go up 2, right 1. So up 2, 1, 2, right 1. Up 2, right 1. Up 2, right 1. And so my line looks like that. So this asks us, how does that change the graph? And when you notice, the red line is a much steeper line than the parent graph. We're going to do 1/2 x plus nothing, so this is up 1 over 2 starts at 0. So it starts here at 0, up 1 over 2, up 1 over 2, over 2, and the blue line is flatter. So what is the role of M? M makes it steeper or flatter. We usually tell students that steeper are numbers bigger than 1, and flatter are fractions less than 1. Okay? So fractions are flat, bigger numbers are steeper. Alright, so now we have the parent function here graphed again, y equals x, and now we're going to take a look at what happens when you introduce a negative in front of there. So we have a slope of negative 1 in this. So that means we're going to go down 1, right 1. Okay? And it's still going to start at the origin. So it's going to start there, down 1, right 1, down 1, right 1. And so this is the line we get. So how does negative 1 change the graph? Makes it go down hill. Okay. If we try a negative 2 on there, this is still going to cross that 0, and now it's going to go down to right 1. So down 2, right 1, down 2, right 1, down 2, right 1. And so this is what our line does. So the negative 2 makes it go downhill and steeper. The 2 makes it steeper, the negative makes it go downhill. The negative 1/2 x, this one, is going to be down 1, right 2, still going to cross at 0. So down 1 over 2, down 1 over 2, down 1 over 2. And so you can see it is downhill and flatter. So what is the role of m when it is negative? The negative part just makes it go downhill. Alright. The last thing we're going to look at here is when we change the n number on it, when we change the b. So again, we've graphed the parent function y equals x, and now we're going to graph y equals x plus 3. So this has a slope of 1, so that's going to be up 1 over 1. But this has a y-intercept of 3, so that means we're going to start at 0, 3. So we start up 1, 2, 3. And then we're going to go up 1 over 1, up 1 over 1, up 1 over 1. And this is our line. So how does the plus 3 change the graph? All it did was shift it up. Okay. This one still has a slope of 1 over 1, so that's up 1 over 1. This time it has a b of 0, negative 3. So we're going to start down 3, 1, 2, 3. And then we're going to go up 1 over 1, up 1 over 1, up 1 over 1. And so here is our line. And so from the parent function, this is shifted down, shifted down. So what is the role of b? b shifts the graph up or down. Up if it's a positive, down if it's a negative.